It is 9 o'clock on the west coast of Canada, so we're going to kick this off today. Welcome everyone to the February 8th edition of the Vancouver Power BI and Modern Excel User Group Meetup. I'm Ken Pulse, and I'm just going to give you the brief intro here before we turn it over to my friend Charles Williams to talk about speeding up and debugging Excel formulas. So today's meetup, well, I'm going to skip past this one because we know where we are right now. First thing I want to do is mention our sponsors that host this event. So SkillWave is the training company that I run with myself and my partner Matt Allington. We run a lot of training on advanced Excel technologies, working with Power Query, Power Pivot, Power BI, and to truly help you get the most out of your data when you're building your business intelligence solutions. Excel Guru is the parent company of SkillWave and also the distributor and developer of Monkey Tools, which is an add-in to help build better data models faster. If you haven't checked it out, you definitely should. Excuse me. All right, let me go. So our next meetups that we have coming up, we've got another meetup in a couple of weeks. We're going to be having, oh, there we go. Let's go backwards here. We're going to be having Roland Surmai, who is going to be joining us to talk about data flows, looking at some Power Query in the web for Power BI. It's going to be fantastic. So practical guide for business users there. We'll be starting at our regularly scheduled time of 5 p.m. Pacific. That's going to be on Thursday, February 22nd. And the next Excel Track meetup is going to be March 7th. And in that meetup, I'm actually going to be showing you what's new in Monkey Tools. I've got a brand new feature that I'm going to be releasing that day as well, and we'll talk about some of the cool things that you can do with Monkey Tools, both in the free and pro version of that software. If you are interested in upskilling your Excel skill set, or you have someone on your team who you think should be working with Power Query and pivot tables and learning more about data visualization, we have our Excel Fundamentals Bootcamp. Our next kickoff date for this is Valentine's Day, where you can get to really know and love your data. If you're interested, you should definitely check that out. Also, for those of you who already know your pivot tables but are looking to take your skills to the next level, learning more Power Query, dimensional modeling, DAX formulas, Power BI, this is our sort of flagship training program here. It comes with a free subscription to Monkey Tools and up to 23 sessions a year where you can ask Ken anything you want. If you're interested in a comprehensive coach training program like that, you should definitely check that out. Once again, our next kickoff date for this is on February 14th. This meetup, as all meetups, are recorded and hosted on the Vancouver Power BI User Group YouTube page. As soon as I have that recording ready, I will post in the meetup site. So if you've RSVP'd for the meetup, you will get the notification that that has been posted, and you can go back and check it out at your leisure. If you're interested in some bite-sized training, we've got a couple of Monkey Shorts videos up talking about column profiling and sorting Power Pivot backslicers and pivots. There's a full playlist you can find at Monkey Shorts on YouTube. You can definitely go and check that one out. Each of these is 3 minutes or less of technical content end to end, so real bite-sized stuff. And finally, the last slide that I have on this one is if you would like to come and speak to our group, you got a cool tool you want to talk about, some neat techniques you want to share, we'd love to hear about them. Please just fill out this form right here. We'll get in touch with you and get you on our stage. And that is what I have for me for today, Charles. I think it's time to turn it over to you. So if you want to share your screen, let's kick this meetup off and dive into your awesome tools here.
Let's see, I just got to get the right screen. Yeah, that looks about right.
Perfect. All right, I can see a really tall screen with PowerPoint down the side, like all your slides. So I'm not sure if it's the right screen.
No, it's not. Bugger. Wait a minute. How do I fix that?
When you share, I think you get a choice of which screen to share. You probably picked the one on the top left. Try grabbing one of the other ones. So you'll probably have to stop sharing first.
Yeah.
Here, I'll tell you what. I'm going to take over with a share again. I'm just going to go and put it this way here. So now it's your turn. Oh, there we go. I'm in the completely the wrong place. So try and share again, but this time try and pick a different screen on yours.
Yeah, it's not showing me the screen I want to show for some reason. It's showing me the tool vertical. What's that?
That's better. Yep, that's better. I got a landscape one now with just one slide. Perfect.
Right. Okay. Well,
the good news is, Charles, we're good with Excel, right?
Oh, okay. Yeah,
There you go.
absolutely. Sometimes.
There you go. Awesome.
And
It's
some
all
of
yours,
us-
my friend.
some- I hear some of us are good with Power Query too.
Oh, maybe. I don't know. We'll see. All right, man. It's all yours. Floor is yours. Take it away.
Okay, right. So I'm Charles Williams. That's my email there, charles@decisionmodels.com. So feel free to email me if you want to discuss anything relevant to today. I got a website, decisionmodels.com. That's full of fascinating information about Excel's calculation methods and about my FastExcel product. And there's a blog, FastExcelWordPress.com, which has got zillions of interesting, fascinating blog posts about how to make Excel and VBA and C++ and all that kind of stuff go faster, with occasional blogs about wine tasting as well. But, hey, Excel isn't everything in life, or even if it's nearly. So, agenda for today. We're going to cover trying to find calculation bottlenecks with FastExcel Profiler. I'm going to start by looking at the results from profiling a rather complicated budget workbook. It's got about 50 worksheets, and initially it takes around 90 seconds to recalculate, which is too long. Then we're going to sort of segue into examples of speeding up formulas. We'll look at the profile of the workbook, but we'll look at lots of different alternative ways of doing the same thing, because I think that's the best way to sort of compare and contrast different approaches to things, and gives you some ideas about how you might start changing your formulas to run faster. Because the good thing about Excel is there's 26 million ways of doing the same thing, and some of them are faster than others. Then, if time permits, we'll get on to understanding and debugging formulas with my Lambda Explorer add-in, which is a free add-in, by the way. And it's great that Sergey is here with us on this call, because one of the things we're going to be looking at understanding is one of Sergey's famous Lambda functions. And then finally, or possibly not in that sequence, we'll cover the 4 golden rules for speed up. Because, I mean, what we really need, I think, when dealing with trying to increase Excel workbook performance is a method of doing it that's consistent, a process that works on how to do this. And so that's my attempt at doing that, is my 4 golden rules. So first thing to say is Excel calculates fast, even if occasionally you do find a workbook that takes 90 seconds to recalculate. So for example, I have a workbook with 5 million very, very simple formulas in it. Each formula adds 4 cells together. And so we're doing a total of 20 million add operations. And if you want to guess how long it takes to calculate, the suspense won't kill you. On this laptop, which is not, total state of the art, it takes about 1 second to calculate. So that's 20 million operations a second. Not bad. Now, so the question is, why do our workbooks take so long to calculate on occasion? How can we make them faster? So FastExcel is my commercial tool, and one of the major things in it is the FastExcel Profiler. And the idea is to find and prioritize the performance bottlenecks in your workbook. Because there's no point, if something's fast already, there's no point in optimizing it. What you want to do is find out which of the formulas in a workbook are slow, and then get down in there and start changing them around to make them run faster. So I'm mainly going to be covering the easy way of using FastExcel Profiler is to click the drill down profiler button. And that starts by analyzing a workbook and deciding which are the slowest worksheets and sequencing them in profile so that you can, in priority order. And then it will take the worst worksheet and drill down into that and profile the formulas on it and show you which are the worst formulas. Now, personally, of course, I tend to use the actual profile workbook and profile formulas functions, commands, because they offer you a few more options than the drill down profiler, which is a kind of simplified way of doing things. So that's what we're going to be looking at. Over on the right-hand side, we've got various calculation buttons, and these all time different kinds of calculations. The one we're going to be using most is calc range. And what that does is it times the calculation reasonably accurately of a single formula or a selected range of formulas. And there's also, obviously, we can time calculating a single sheet or recalculating a sheet or calculating all the formulas on a sheet, and similarly with a workbook. And FastExcel, by the way, also has some extended modes, calculation modes, that allow you to only calculate whatever the active workbook happens to be, or indeed you can set different calculation modes for different worksheets. So some scenarios it's useful to be able to refine the calculation to a more granular level than the standard stuff you get with Excel. It also has a VBA profiler, as you can see from the commands below that. I'm not going to cover that today. We haven't got time. So I just want to talk a little bit about multi-threaded calculation. This is probably the biggest innovation in calculation in Excel, certainly from a performance point of view. And what Excel does is it tries to spread the calculations across all the cores on your machine so that it can calculate them in parallel. And, you know, today's machines have more and more cores. This machine has something like 20 different cores. Well, actually, it doesn't really have 20 cores. I think it's got some sort of efficient cores, and the others are different cores that have hyperthreading and so on. So yeah, lives get very complicated these days with the advances that we have on our PCs. Now, the thing about multi-threaded calculation is it's great when it works, but there's an overhead in terms of trying to work out how to spread the calculations across all the cores. So sometimes it's slower to use multi-threaded calculation. I had a guy last month with a machine that's got 96 cores on it, and he was complaining about how his workbook was running slow despite these 96 cores. And it turns out that it was actually faster to run the calculations using one single thread, one core, rather than all the 96. So the overhead was dominating things. Now, the other thing to be aware of is there are some nasty single-threaded things that slow things down, that force Excel to be avoiding multi-threading, spreading the calculation across the cores. Indirect, Excel's most evil function. Not only is it single-threaded, it's also volatile. Get pivot data, Excel's next most evil function, is also single-threaded. I think people think it's evil because it's so horrible to use. Cube functions, circular references, when you're doing, when you switch on calculating circular references, Excel uses a different single-threaded calculation method and just does things left to right and top to bottom, rather like Python. Iterative data tables are also single-threaded, which is bad news because they're slow. And VBA and automation UDFs are also single-threaded, although sometimes they can be fast. The UDFs I tend to write in FastExcel are written in C++ using the XLL interface, and those can be multi-threaded, so that tends to be good news. Okay, now let's see if I can switch into, have enough PowerPoint for the moment. Let's go to Excel. Right, so here's the output of FastExcel Workbook Profiling on this complicated, nasty budget workbook. So up the top there, we've got, by the way, is that large enough for people to see? Or do you want me to magnify it a bit more?
I think it's probably okay, Charles, but if anybody wants it increased, please just throw something into the chat and I'll relay that back to Charles. I've got an I can see, so we've got a, 2 votes out of 2. We're out of a bunch so far, but yeah, go with it as is, Charles, for right now.
Okay, great. So up top here, we've got some sort of just documenting the environment kind of stuff. Tells you, what machine you're running on, what version of Excel and Windows and stuff like that. And then all the general settings for the workbook and all the calculation options and stuff, so that, you've got a record of how this workbook was used, what machine it was used on, and what the settings were. So that's just for the record. Then we come down to the important stuff. So it has got 40 odd sheets, this workbook. I've chopped most of them off because they're, fairly boring. And we can see here, this is the worst sheet, NE, and it's got 50,731 formulas, and of which 148 are unique. Now, that cell is highlighted in orange, which is a kind of warning signal that maybe you ought to look at something there. And if we hover over the cell with a nice little red dot in the corner, that says, okay, it tells you what this column of data is all about. It's a count of the unique formulas on the worksheet, and it's colored orange if one or more formula contains an explicit full column reference, because full column references can be slow. So, maybe that's something we ought to look at. Next column says Control-Shift-Enter formulas. We haven't got any of those. And then we've got conditional formats. Now, one of the slow parts of Excel, funnily enough, is screen updating, rendering stuff to show on the screen. So you get in the fascinating situation where if you've got a whole lot of screen estate, real estate showing Excel, multiple screens, high resolution stuff, Excel may be running more slowly than somebody who's running on a nifty little small screen. And this is particularly true with things like conditional formats that have to be evaluated at screen painting time. So Excel does the calculations and then it works out how to change the display of the calculations. And the screen updating only takes place on whatever is visible. So the worksheets that aren't showing, doesn't care about those because it doesn't have to show them to you. So down the bottom, we've got some orange stuff on some of these worksheets. And that's saying that on average, there are more than 3 conditional formats per cell that's got conditional formatting. Now, there was a nasty little, could call it a bug or a feature in the various versions of Excel that tended to, whenever you changed a conditional format, it sort of splintered things. So you wound up with very large numbers of conditional formats in cells. And that could be slow. So that's why we look at them and try and highlight a possible problem, something to look at. This workbook doesn't have any what if iterative data tables, but if it did, it would be highlighted there. And then we've got 3 columns of calculation times. These are shown in milliseconds, that's thousandths of a second. So first of all, this worksheet takes 49 seconds to calculate 49,000 milliseconds in single-threaded mode. If I force it to run to calculate that worksheet in single-threaded mode. When it recalculates, which is the standard Excel stuff, it takes 52.9 seconds, 52.9 seconds. And full calculation takes 54 seconds. So this is a seriously screwed up sheet. Now, if you look at the recalc time is very similar to the full calculation time. So that means that most of the sheet is volatile. most of the formulas on that sheet get calculated whenever anything changes or whenever calculation takes place. So it's 97% volatile. And most of these sheets are in fact quite volatile if you look down there. Multi-threaded efficiency, well, it's not great. It's saying it's around about 1. What we want is a high number. So that's roughly says, how many cores it's managing to use to calculate the formulas. And then we get into the more statistics about how fast each individual formula is on average, whether there's any waste on the sheet in terms of use range and so on. So this gives you a method of prioritizing which worksheet to look at and a preliminary idea maybe of what you ought to be looking for on that worksheet to speed it up. Then we can see there's 40 sheets in total, and it gives you the totals for the workbook. Overall, the workbook is 84% volatile. So because recalc is very close to full calculation time. It's actually slightly more efficient than it appears from looking at those from a multi-threading point of view than it appears from looking at those worksheets, because all the other worksheets that I'm not showing are more efficient and are managing to multi-thread reasonably effectively. So, okay, so now we would look at the worksheet NE and look at the formulas on that worksheet with the worksheet formulas profile. So that would be pushing that button up there to do profile formulas. Okay, so the first formula, which is horribly complicated formula, is using 48% of the total calculation time on that sheet. There's 3,264 of this formula, but it's still pretty slow on each individual formula. So we need to do something about that. If we look at the actual formula, it's moderately horrible. I can actually look at it using Lambda Explorer, and it will show it to me in nice indented form, which is easier to look at. Okay, and I can step through the thing in detail and see what each of the individual stuff is going. We'll look more at Lambda Explorer later on. Just wanted to show you that you've got a good method of indenting formulas and making sense of them with that. So let's move on to what I actually did to change things. Changes on these sheets, and the 3 very similar sheets that all had the same kind of thing. Yeah, they had indirect. That's why, I should have mentioned this orange stuff over here. These flags tell you descriptive flags about the formula. So the B says it's using standard Excel functions, native functions. The V says this formula is volatile, and the S says this formula is single-threaded. So, right, this is a real culprit. So, not surprisingly, when we look at it, it's got indirect all over the place. And they were using indirect to avoid problems when they inserted extra rows. So they wanted to have a formula that always referred to the row above it, regardless of what changes were made to the worksheet. They were using indirect for that, indirect with cell. But there's a better way of doing it, using index, and we just index the whole column and feed it the row number as current row number -1 and the current column. So getting rid of that, index is fast. So getting rid of that indirect removed a lot of the volatility and made things fast. Then in some of the other columns, there was a complicated formula that had a repeated calculation that was used in various if statements and stuff. So it essentially wound up to derive a column of trues and falses. And so I took that out and stuck it in a let statement. And let is a sort of filtering statement. and then reuse the result. I can reuse the let in the actual calculations in the rest of the formula. So that was, again, you know, getting rid of a repeated calculation to only do it once. Let's a great tool for doing that. And similarly, in the next columns, we did that. So the overall effect of doing that and various other changes looks like this. Here's the before stuff. So it was taking 96 seconds to recalc, 113 seconds to do a full calculation. So you're definitely running in manual mode, because 96 seconds every time you change something would not be a good way to go. Then making these changes drastically improved things. We got the recalculation time down to 3 seconds and the full calculation time down to 30 seconds. And the 3 seconds were what was left on these 3 sheets. And we didn't really, they were even more complicated sheets, and we didn't have time to look into it. We almost certainly could have found a way of speeding that up even more, but we kind of left it at that. 3 seconds they thought was good enough improvement from 96 seconds. I think it wasn't too bad. Okay, so that's an example with a complicated, horrible workbook. Let's now switch to this. So this is the profile of an example workbook that, as I said, does things in lots of different ways. So there's a SUMIFS calculation. There's lots of 6 different unique formulas on the sheet, all of which do give you the same result, but they have different performances. So we've got that for SUMIFS and for count uniques, period to date calculations, counting stuff, and so on and so on and so on. So we can see that the SUMIFS sheet is one that's really killing this workbook, but the volatility is pretty good. The recalculation time is fast. It's 56 milliseconds. You never even notice that. Anything less than a second is pretty much instantaneous. Anything more than a second, you start having to go to manual calculation mode, which is not good. So but the full calculation time is mostly in that sheet, and it's mostly on one single formula. Okay, so if we look at the formulas on that sheet, look at the formulas profile, we got the same kind of story. Okay, this is a sum product formula that's using 96% of the sheet time. And yeah, there's lots of faster ways of doing it, because each single formula takes 139,000 microseconds. So that's 0.1 of a second, which is pretty slow. But the fastest one's only taking 433. So there's a lot of scope for improvement. Similarly, we can go through all the other ones, but really what's more interesting is actually looking at the workbook itself. So let's do that. Right. So we're starting with the SUMIFS calculation. So what we're trying to do is sum column F, which is these numbers, over 10,300 rows of data using these 5 filter conditions: start date, end date, to city, to country, and the from country. And the first attempt is SUMIFS. So we can see the SUMIFS. It's using full column references, and it's pretty fast. It takes 17 milliseconds on a good day. Now, because we've got Teams and God knows what running on this machine at the moment, it's probably slower than it would be when we were, I don't know, doesn't look too bad. Don't know whether you can see that, that's quite small. So I clicked the calc range button and it calculated all the selective cells, 22 cells in selected range, 17 milliseconds. So that's fast. Now, the interesting thing about SUMIFS is the way it works. Because you've got multiple conditions in there, the way it works is it takes the first condition, applies it to all the data, and that gets a subset of rows which get passed on to the second criteria, which further subsets things, passed on to the third criteria, and so on. So it's a sort of funneling down effect. So guess what? If you make the first criteria condition, the most restrictive one, the one that's going to result in the fewest number of rows, it runs faster. So when I change the sequence to run with A first, then E, then and so on, the calculation time went from 17 milliseconds to 5 milliseconds. Now, yeah, okay, 17 milliseconds was fast enough. Who cares? But if you got a lot of these formulas and a lot more data, you would start worrying about this. So we'll just check that calc range 5.05 milliseconds. Unnecessary accuracy there. Just to demonstrate, I can calculate a single formula and it'll give me a reasonably accurate time for a single formula in a cell, 0.3 milliseconds. It's using a timer which is accurate to about a microsecond. But of course, Windows being Windows, there's all sorts of stuff going on in the background, so timings are never actually repeatable. Now, here's the sum product formula, which is the culprit. And it's sum product using full columns. And that's bad news, because unlike SUMIFS, the sum product has to work with the whole array. The SUMIFS will work with whatever the used range is. So it'll only, as long as you haven't got anything silly like formatting down in the last cell and column, last cell and row, it'll be efficient with full column references. But sum product has to work with, in this case, all million rows for each of these columns, and has to take them all and create virtual columns, arrays in memory, multiply them all together, do the comparison tests. And so this set of formulas takes 3 seconds, not 3 milliseconds, 3063 milliseconds to calculate. I'm not going to do it because, hey, that'd be slow. We might try one single formula and see what it does. 288 milliseconds for a single formula. Okay, slow. Now, so when we change things, get rid of these full column references in SUMIFS, like that, so we're only doing the 10,000 odd rows in each of the criteria. It doesn't really speed up very much compared to when using the resequence method again. So this is 5 milliseconds. That was the same as the full column references. So SUMIFS is very efficient at handling full columns, but there's a drastic change in sum product. It now only takes 53 milliseconds to recalculate, compared to the 3000 milliseconds with the full column references. So, and here we've got same thing using the new filter function. Again, I've done that using just the ranges. Interesting to compare sum product and filter. In this case, there's not a lot of difference really, because they're both under the hood. They're both doing the same thing. They've got to work with all the data that you give it, create virtual columns, multiply them together, and do all that kind of stuff. So they're both really array functions. Okay, so moral of the story: SUMIFS, COUNTIFS, good news. Sum product, be careful. It's always slower than SUMIFS and COUNTIFS and stuff. But sometimes you can do things you can do more complicated things with sum product than you can with SUMIFS. So sometimes use it, but don't use full columns. Next one is count uniques. So what we're doing is we've got 10,300 rows of data again, and we're trying to find out how many uniques there are in there, but ignoring blanks. So we start with a little array formula that says, here you can see it, and it produces the answer 420, and it takes 1.3 seconds to calculate. Yeah, 1,323 milliseconds. Now this calc range thing, what it actually does is it does it 3 times, and it takes the median result of those 3 times to try and iron out the kind of Windows is doing things in the background to try and give you a more accurate, a more consistent timing. So when you do it for something that actually takes 1 second, it's going to take 3 seconds because it's doing it 3 times. Some products, very similar time to the native array formula. Takes virtually identical. I wrote a VBA user-defined function just to do the same thing, and that runs a lot faster. It is single-threaded, so if we had a lot of them, that wouldn't be quite so good. But it's only taking 19 milliseconds compared to the 1.3 seconds for sum product and the array formula. Then, as part of speed tools, there are about 100 additional XLL C++ multi-threaded functions that are pretty fast. So they're an alternative way of speeding things up. And one of them is the count distinct function, which just counts the number of different things in the range that you're throwing it. There's various options on it. That's nearly twice as fast as the VBA, and it's multi-threaded, whereas the VBA would be single-threaded. But of course, actually, we don't need any of this fancy stuff. There's better ways of doing it with native Excel formulas. So in this one, the sorted helper column, what I did was build a helper column that says if, let's just look at it from trace precedence. Okay, so each formula is looking to see if the cell on the left is the same as the cell above it. And if it is, it's 0. If it's different, it's 1. So we can see here, yeah, whenever we get a change, we get a 1. So that's a helper column. Then we can sum the helper column to do the calculation. So that's getting the same result, but the helper column takes 2.2 milliseconds to calculate, and the sum itself only takes 0.5 milliseconds. So we've got the time down from the 1,335 milliseconds down to 2.7. And this is a good method because breaking things up into a helper column or breaking a mega formula up into pieces, into multiple cells, exploits both the smart recalc of Excel. It's only, with any luck, it won't have to recalculate. If I change one thing here, only one formula is going to have to recalculate. 2 formulas are going to have to recalculate in that helper column, not the whole thing. Whereas if I change one thing there and then change the array formula, recalculate the array formula, it would have to recalculate the whole thing. So breaking things up allows Excel to exploit the smart recalc to make things better. And of course, it also exploits multi-threading because now we've got things separate. They can be assigned to separate threads. So that's the reasons why breaking things out, building helper columns is good from both they're easier to understand and they run a lot faster. Now, I was interested to run a dynamic array formula on this. because I wasn't quite sure whether dynamic array formulas were going to be fast or slow for this particular calculation. And it turns out that using a let and count A and filter and stuff, you can see the formula there with any luck. That's the fastest method. It only takes 1.2 milliseconds. Wow. So yeah, well, in this case, it only takes 0.76 milliseconds, even faster today. So that's interesting. Two things to bear in mind here. Breaking up your mega formulas and using helper columns and stuff really gets to the bottom of how to make Excel run faster, because you're exploiting the native abilities. And then the dynamic array formula, yeah, great. That's proof that modern Excel has got its game right. Next one is summing period to date values. So we've got a lot of data here, dates and values. I just want to be able to say what's the running total as we go down here. So if we look at that particular formula, we can see that it's summing all that block, and this formula is summing all that block, and so on. So we've got 5,000, so we've got 10,000 formulas, one for each row, and on average, these formulas are doing 5,000 calculations, because the further down we go, the more, when we get down to the bottom, they're doing, they're summing up 10,000 cells. Halfway up, they're summing up 5,000 cells. So that's not great, really. So it gets progressively slower the longer that thing becomes. So guess what? There's a much simpler way of doing it. We can build a little formula that says, okay, I already know what the previous to date is, so I'll just add that in. I'll add in this value and the previous value. Similarly down here, previous value and this value. It's getting the same answer, but guess what? Look, it's only referencing 2 cells on average. So that's compared to 5,000 cells being referenced in this sum formula. This formula is only referencing 2 cells. So in theory, it ought to be 2,500 times faster, but of course it's not, because there's other overheads in terms of interpreting the formulas, etc., doing the screen refresh, and all that other stuff. So actually, this sum formula takes 153 milliseconds, and this formula takes 8.5 milliseconds. So yeah, it is a lot faster. Now, again, I wrote an XLL function, accumulate, as part of the speed tools functions, and that's even faster. It takes 2 milliseconds, so it's about 4 times faster than that amazingly fast formula. Tried looking at what happens when we use the fancy stuff with a lambda and the scan function. I find scan quite hard to understand, I have to admit, but it gives us the same result, and it's reasonably fast. I mean, it's only taking 5 milliseconds, which is still faster than the very, very simple formula. So that's good. Okay, so what that tells us is, yeah, we can save a lot of time by building our formulas in such a way they don't reference as many cells. And that's one of the performance tricks that we need to look for each time. Next one is counting rows where all numbers are greater than 100. So we've got 500 formulas on 2,000 rows. So the first formula is this one. So it's a sum, it's an array formula using sum, and it takes 180 milliseconds to do the calculation. The sum product formula is virtually the same, 193 milliseconds. Countifs Yeah, well, we like countifs. 74 milliseconds, that's definitely faster. But again, if I break it up into a helper column, so this is just a, let's go to the actual thing up here at the top in the formula bar. So there's a single formula that says if column A is greater than 100 and column B is greater than 100 and column C is greater than 100, it's a 1, otherwise it's 0. So we just put that formula down as a helper column, and then we sum the helper column. So the column of formulas that are doing the simple if and only takes 0.6 milliseconds, and the sum only takes the remaining 6.9 milliseconds. So the total for the sum column, for the helper column, and the sum of the helper column is only 7.5 milliseconds. So again, and good news, we've broken things up into helper column, lots of different formulas. It's going to be much faster in real life with Excel. It will exploit the smart recalc and multi-threading. Now let's look at, how are we doing for time? Not too bad. Let's look at lookup values, lookups, people's favorite formula. So I've got, I'm going to do 5,000 lookups over 20,000 rows, and some of the data that I'm trying to find in the 20,000 rows is not there. So I want to get an error, or I just want to find out that they're not there. So if I do a standard VLOOKUP, with using unsorted data, yeah, I get a hash NA when the data doesn't exist, and it's not too bad. It takes about half a second, 500 odd milliseconds to run, and I can add an error handle to get rid of that nasty hash NA. Just wrap it in an if error, and it really doesn't add anything to the time. It still takes 497 milliseconds. Now, of course, since the data is sorted, if I use the sorted option on VLOOKUP, it runs a lot faster. So this set of formulas only takes 2.5 milliseconds compared to the 500 milliseconds for the unsorted data. And bearing in mind, guys, this is using speedy lookups, which are supposed to be much faster than the old lookups, but they're still quite slow. And then I can, but the problem with using the sorted version of VLOOKUP is it gives us the wrong answer when the thing we're trying to find doesn't exist, because that's the way sorted VLOOKUP works. We can handle that, so that's a big drawback to its speed. We can handle that by doing the double VLOOKUP trick. So if we look at that formula in more detail, so we do a lookup. We look itself up. So if the thing we're looking up, B5, in the column is not the same as the B5, in other words, if it doesn't find itself, then it's not there, and we'll return an empty string in this case. But if it is there, then okay, I do the proper VLOOKUP and return the real answer. So double VLOOKUP, so it's slower than the single one, but it fixes the missing data problem very neatly, and it's a lot faster than the unsorted VLOOKUP, even with the speedy lookups. Now, then I tried XLOOKUP as well, using the unsorted version, And for some reason I don't quite understand, it's a lot slower, 957 milliseconds compared to the 497 for VLOOKUP. Don't know why that is. It's got to be, usually when I've done comparison performance tests of XLOOKUP and VLOOKUP, XLOOKUPs, yeah, it is a little bit slower, usually about 10% or so. In this particular case, it's a lot slower, and I don't really know why. I have to talk to Joe McDade about that, I think. Okay, so we've looked at various things, comparing ways of doing things, and different methods of, I'm going to switch back to PowerPoint if I can get there. Come on, machine. See if I go like, oh no, it's not touch screen. Not letting me switch.
Hey, Charles, before you switch back to PowerPoint, do you want to pause to take questions on the stuff before you move on to another section, or?
Okay, yeah. Well, we're just going to do the golden rules next.
Okay.
Which is a neat segue. If I can manage to, for some reason, it's not letting me go across to my other screen. Hang on a minute. Let's go back to here.
Got it. I can see.
Right. Okay. Right. Good. Golden rules. 4 golden rules. Rule 1. Get rid of duplicates, repeated, unnecessary stuff. We've seen that working in terms of the examples I show. So one of the key things to look at in a formula is, how many cell references are we asking Excel to do? How many calculation operations are we asking it to do? Can we reduce that? Can we use helper cells? Can we use lets? Can we store stuff in separate additional rows and columns as intermediate results? Now, let, of course, is great if the stuff that's being repeated is within the formula. But if it's not, if you just want to use a calculation once and then reuse it elsewhere, additional rows and columns for intermediate results are a lot better. Now, if you get really desperate, of course, we can always use copy-paste values to convert the formulas that you don't want to change anyway back to values so they don't calculate. And of course, it's usually a good idea to keep a copy of the formulas as text so you can switch it back again. And sometimes you can minimize the scope of the calculation, particularly with if. So we've got to use rule 2, use functions efficiently. If is critical here because it short circuits things. What that means is it doesn't execute the 2 parts of the formula. It does the test first, and then it only executes the true part of the formula. So you can put a switch in your model to say, well, okay, I don't want to run this scenario. So if this scenario switch is false, don't run this formula. When it's true, do run this formula. And that can be a very effective way of speeding up your calculations. Next lookup. Yeah, well, maybe it's not quite as fast as it should be. Be careful with UDFs, minimize number of cells, get rid of sum product and array formula where possible. So we've seen examples of all that. Then, yeah, smart recalc, that's critical, and multi-threaded. So indirect, yeah, Excel's most evil function. It's volatile and single-threaded, and there are other nasties about it too. Offset's volatile, but it's fast. I've built a mega workbook that used offset all over the place, and it ran like grease lightning. Multi-threaded recalc's good, minimize the size of ranges, and separate helper columns and rows, yeah. 4th golden rule, time things and test them. So time the formula before you change it. Make a note, make the change, time the formula again. Maybe it isn't faster. Maybe what your change is makes it slower. So that's important. And of course, check that it gives the same answer as it did before. Critical point, because anytime you make a change, yeah, you could be introducing a bug. Okay, questions?
All right, we got a whole bunch in the chat here. So let me go back to the beginning here. So all right. I'm probably not going to hit all of these just for reference for folks on this, but Baljeet was asking, does FastExcel Profiler look at Python?
No, it doesn't.
All right, that was easy answer.
Python operates up in the cloud, and FastExcel can't reach that far.
Fair enough. Is your profile constant or dynamically updated?
It's constant.
Okay.
So it's a static report. It's produced as a separate workbook. So you have your workbook active, you run the profiler, and it produces a separate workbook that contains the profile report sheets as we saw.
Perfect. How do you fix fractured conditional formats?
With difficulty.
There you go. Good answer. All right. On the volatile percentage, what does it mean when the volatile percentage is over 100%?
It means there's some discrepancies in the timing.
All right. So another question, in the environment, is temp referring to the core and chip temperature?
No, that was the number of files in the temp directory. It's not a temperature thing. A lot of software leaves stuff hanging around, temporary files, and when they get to large numbers, it starts slowing things up. So it's a reminder that maybe you ought to clean out your temp directory.
Fair enough. All right, on the so Thomas has asked a question about the named range changing the result F2 to F10,001. So I think this is, if I'm getting this correctly here, I think this is a thing rather than referring to the column. If you referred to a named range, would that be better or more performant?
No, it isn't. The answer is no. The named range is, you stick a formula in a named range, it gets executed every time you refer to that named range. So it doesn't, it's not like a let, which stores the result, which you then can reuse. Named ranges or named formulas, because all named ranges are actually named formulas, they get executed every time they get called. And so there is a slight overhead on calling them as well. So in theory, it's slightly slower than not using them.
Fair enough. Okay, now this was one that came up in your count unique example. Ron asked, why would the VBA UDF be faster?
Well, why wouldn't it be? I don't know how to answer that.
I do, because Charles is really good at writing UDFs. That's why.
Yeah, I mean, I could write a bad UDF that did the same thing, and it would be millions of times slower. I mean, there's, you have to be careful when you're using VBA to make it run faster. It's one of the reasons I wrote that VBA profiler thing.
Yeah, for reference, if I wrote the VBA UDF, it would be slower. So, all right. Also, yes, just to confirm, it's not the helper column that's sorted, it's the source column that's sorted, then the helper is generated.
Yes.
Okay, there you go. Does the dynamic array formula also assume a sorted source column?
I don't think it did. There was more than one dynamic array formula, so I think the one we were looking at.
This is still on the unique sheet.
Yeah. If I go back to it. Count uniques. This one here.
Yeah.
No, it doesn't assume it's sorted. That's good.
There you go. Cool. All right. Next question was, did you test the speed without wrapping in a Lambda and just using count a unique?
No. It's interesting. Don't know.
Next edition of the presentation may have this. All right, and last one. Okay, so golden rule number 4: do you time all formulas or just the formulas you calculated?
I just the ones I want to change. So you run the profiling stuff. So find the slow sheets, find the slow formulas, and then you want to make changes to that particular formula to see if you can make it run faster. So using range calculate, you're only timing that particular formula or block of formulas.
Go.
Then at the end, yeah, I'd probably rerun the profile at the end.
There you go. So the last question, and I have feelings on this one, but any idea? ChatGPT picking a formula you asked for randomly, if you could ask it to present a fast formula. So I think basically, if I paraphrase that one, when you're asking ChatGPT to provide you an Excel formula, do you think you can or should ask for a fast version? I'm like, my personal feeling is I'm just trying to get one that works out of ChatGPT that actually works in Excel, but I don't know if it would be smart enough to know that I mean, having said that, it could. I don't know. Do you have any experience working with ChatGPT on formulas?
Not great experience. I don't think it's sophisticated enough to. Well, maybe it is. I don't know. I haven't tried it. I'd have to. We could do it on this some of these samples. See which formula it picks.
Yeah, I mean, my experience working with ChatGPT is that it typically takes, I mean, it's unusual for it to take less than 3 to 5 iterations of going through something to try and, fine tune the results to get them right, let alone to be, in a high end for performance and things like that. Having said that, that could be the way I'm asking the questions. It could be the formulas that I'm working with and whatnot. People have different results working with this stuff, but I would say try it and see what happens. It would be interesting to see tests after the fact as to whether or not it actually provided you something that did provide better, though.
Yeah, so, I mean, I think a really great one to try it on would be a really simple thing like period to date values, and see what. I bet you it comes up with that sum B2 to B6 formula.
That'd be my guess too. Yeah, exactly. Which, I mean, has its advantages, right? If somebody inserts a row in the middle, it's going to be fine. But but at the same time, I mean, perf wise, it's not, right? So there you go. So I think that's all the questions for right now, Charles. So
okay,
I think you're going to dive into something else, right?
Yeah. So we got time for Lambda Explorer now.
Cool.
Great. Okay. So let's start with a simple little if formula, and we'll run it through Lambda Explorer. And here we go. So, I mean, there's nothing particularly complicated about this formula. I just wanted to use this as a very simple example to show you that it's tracing through the logic and highlighting in green the bits that are going to get executed. So when you get if you had a much more complex if formula with infinitely nested stuff and lots of brackets all over the place, this could be a neat way of doing things. When we select something, either up here or down there, it selects the appropriate thing. I can run through it in debug mode and just using the arrow keys, and it'll do it step by step so we can see what's happening. And I can run backwards as well as forwards and all that kind of stuff. So that's a very simple use of it. Slightly more complex if we take SUMIFS statement Again, same thing is true. We've got it nicely indented up there. We've got all the individual expressions down here. And the purple bit, by the way, is a name. So it's a named formula. And the yellow bit, guess what? It's a volatile formula, offset. So as we click each bit, it'll show us on the right what range it's actually referring to. And up here, it'll show you what the actual values in that range are. And one useful thing is, particularly with large ranges, I mean, Excel's sort of formula evaluator tool is was written about 25 to 30 years ago, and it's showing its age rather badly nowadays. And one of the problems it's got is that if you've got a large range, you can't see what the hell's going on. So I built in this filtering technique so that you can, if you're looking for errors in a large range, for instance, it'll scan down there and show you only the errors or numbers or whatever. So that's a useful technique. Each individual expression gets evaluated. So here we've got one of the criteria of the SUMIFS, and what it's saying is this range is the result that meets that criteria. So D6 to D9 is that column greater than the joint filter data. And up here, we've got the actual values that are a result of that criteria. So we can step through the individual bits of the SUMIF and see what they're doing. We can click on any particular bit and, okay, filing choice is actually okay. It's a named formula, and when I clicked on it, it expanded it, so it's doing a match internally. When I click on it here, it contracts back again. So that's a neat way of being able to look at named ranges, named formulas and stuff as you're going through. Now, let's move along to, this is one of Sergey's lambdas. Okay, count same. What it's doing is, up here we got a lot of data, which is a bit small to see. Let's make it a bit bigger. Which has got a lot of rows in it, and some of those rows have got the same numbers, but in a different sequence. So what this lambda function is trying to do is count the number of rows that contain the same numbers, albeit in a different sequence. So if I fire up Lambda Explorer on that, I get this nice purple thing which says, okay, this is a named lambda. I get a little tooltip if I hover over it and say that. I click on it and it expands the named lambda so I can see what's happening. And the green stuff is the parameters that were passed in. So that's the range gets passed in, and it's the array. So wherever that green stuff is, that's something that was passed into the lambda. Then we got various lets. So the first let says how many rows have I got? No. How many rows have I got in the input array? There's the input array, looks the same as the range, and rows of that is 6. So I'm storing that in a let variable called RWS. Well, Sergey's storing that in a lambda variable called let variable called LWS. Same thing with cols, you get the columns out. And then we come to the clever bit. So he's got this function the Lambda function called sort rows. I'm not going to go into that because we haven't got time. It's even more complicated than this. So, but what it basically does is it takes all the numbers in each row and sorts them along the row. So up there on the right, we can see it says 3, 4, 5, 8, 17, 21, 1, 2, 3, 4, 5, 12, and so on. So the numbers have been sorted row-wise. So now we can, if we do a compare of each individual row, looking for the unique ones, we can see, for instance, that 3, 4, 5, 8, 17, 21 is the same as that row. Whereas looking at the original stuff, it's because they're not in the same sequence, it's really hard to see that. So now we can feed that into a unique function. And that shows us that, yeah, now, oh, and I'm using the one option in there, which for unique, that says only give me the stuff that appears once. So now these are all the rows that only appear in the data once. So then I can feed that into the let variable called distinct, and then I can do the actual calculation now. So we can get the rows of distinct, which is 4, obviously, and the rows of the original column. To take one away from the other, and we get 2. So there are 2 rows that are the same. Magic. There we go. So, yeah, without Lambda Explorer, it's quite hard to understand this, particularly when you just come across it in the middle of a workbook. And this is a tool I built because the native Excel tools for trying to do this kind of stuff don't work on lambdas at all. And we really need something that enables us to understand them and debug them. And the Lambda Explorer is also, as we saw, useful for ordinary Excel formulas. Take one more example. This is a recursion formula, which is written by the guys at Microsoft Research to try and see how far you could go in recursing down a stack. So the way Lambda Explorer deals with that is it does it one step at a time. So you can see we've expanded the stack depth lambda, and it calls itself. So if we click that, yeah, it calls itself again. Now at each stage in this, we can see what the values of the variables are. So you can see up here we've got 32 being the value of the variables, and now in the next step it's down to 31, and in the next step it's down to 30, and so on. So that's how it works out what the stack depth is. So this is a method of tracking through a recursive calculation step by step, seeing what the values are at each of the steps. Because of course, if we try and blow the whole thing out to all, in this case, 32 steps, we'd wind up with a horrible, long, messy formula that would be really hard to understand. So that's really all I want to show you about Lambda Explorer. It's a good tool for exploring lambdas in particular. That's really what it's designed for. But you can also use it on ordinary Excel formulas. We've got a step-by-step debug in there. It works well with large ranges and arrays, and with the ability to filter them. We can generally play around with it quite a lot. So, and it's free. In FastExcel, another component is Manager Pro, which has got a better version of Name Manager. That's a souped-up version of the one that Jan Carroll and I wrote, which is available as a free add-in. You've got Formula Explorer, which is a more complicated version of Lambda Explorer that integrates in precedence and dependence and things like that, and better ability to work with analyzing things in that style. But that's it. Okay, that's the end of my formal session. Running about 15 minutes over the hour. Any more questions?
I don't. We got a comment. This is Lambda Explorer's magic. One comment: aren't recursive functions the true evil functions? I love it. I love recursive functions. They're fantastic when you expect them. When you don't, that's a whole different question. But yeah, some positive comments on FastExcel and some folks who've been using it for years. So they want to say thanks for that. But no other questions there. So if there are any other questions, please shoot them into the chat. Now is your time. But yeah, thanks for this, Charles. So here's a question for you: if somebody wants to go and get their hands on either FastExcel or Lambda Explorer, where do they go?
They go to my website, which was up at the start of the. See, I'm having trouble switching back to PowerPoint. So if I go back to the beginning, yeah, there we go.
Cool. And while people are looking at those, and it'd be decision models is where they want to go for that one, right?
Yeah.
Dave has asked, performance-wise, how impactful are recursive functions?
Depends how many times they recurse.
And presumably how big what they're doing, and I would say that each one's probably got to be taken in its own case for that. Yeah. But there you go.
Yeah.
Awesome. I don't see any other questions coming into this one. So, Charles, thanks for coming and doing this. I mean, I've known you for years. I know you've been building amazing tools like these for years, and it's fantastic to be able to actually get you out here and show people what they look like and what they do. If you haven't checked them out, you guys definitely should go and check stuff out on Charles's website. I know I've got Lambda Explorer installed on my machine because I can't have a hope of understanding some of these things without it. Very, very useful tool, and I'd highly encourage you to go and grab a copy on that. Outside of that, Charles, I don't know, do you have any parting thoughts that you want to leave before we wrap up for the day, or?
Oh, just everybody should buy FastExcel. It's just that simple.
Well, there you go. Which is also a fantastic product indeed. There you go. Awesome. All right. Listen, thanks again for coming and doing this. I really appreciate it. Thanks everyone for coming and attending. Exactly as Dave says, makes sense. Just buy it. Thanks everyone for coming. We will get the recording of this posted up. Try to get this done in the next 24 to 48 hours, and I will post on Meetup when it's available, so you can go back and watch the presentation again. Thank you for coming. Don't forget you can sign up for the next meetups, and we'll see you next time. Awesome. We will wrap it up for today then. Thanks again, Charles. I really appreciate it.
And thanks, Ken, for hosting me. It's been great.
Not a problem. And we'll see you at the summit, my friend.
Yeah, absolutely.
All right. Cheers. Bye-bye, everyone. Oh,
Cheers.
Wait, one more question. One more question about people that are in the corporate world installing it and so on. Any challenges to deal with in that regard?
Well, usual problem of installing add-ins. It's they're all code signed. They're all virus proofed. Yeah, but some people don't allow you to install VBA stuff at all. Yeah. Oh, and you need to be a you need Windows Authority to use the regular installer, but there is a way around that of just there's a manual install that bypasses the need for admin rights.
There you go. So, Dave, my advice to you would be that if you're needing the admin rights to install, get in touch with Charles through his website, and he can give you the workaround to that. So, There you go. Awesome. Let's wrap it up for today then. Thanks very much for everyone. We will see you next time.